We've spent the first part of this unit on factoring and solving quadratic equations. So we're actually going to switch gears just a tad. We're still going to solve equations, but we're going to solve something called radical equations. And we need to understand some things about radical equations. We're going to look at the graphs of radical equations to help us with that. But most important with a radical equation is we want to look at the restrictions. A radical equation is not defined for all values. So to help us look at that, we're actually going to look at the graphs of about 3 different radical equations. So we're first of all going to look at the graph of the square root of x. So all I'm going to do is I'm going to go into y equals, I'm going to graph the square root of x on my calculator. And what you notice is the square root of x starts at the origin here, and it goes up and to the right. So what we're going to do is we're going to make a quick sketch of that on our grid. So that's basically what the graph of the square root of x looks like. Now it says state the domain of this graph. Remember, domain is the x values. So if we look at this graph, the domain for this particular graph is x is greater than or equal to 0. And you will also see it sometimes stated with an XER at the end. That means x is all real numbers greater than or equal to 0. We don't have any x values less than 0 because this graph actually stops at 0. Now the next question says, for what values of x is this radical equation defined? Well, that's similar to the domain. Your graph is only defined for values of x that fall in the domain. So it's defined for all values of x greater than or equal to 0. Now, we're going to look at a different graph. We're going to look at the square root of x minus 2. So I'm going to go in here, graph the square root of x minus 2. What you're going to notice is this looks similar, except this graph starts at 2 on the x-axis. So if we make a sketch of this, at 2 on the x-axis, we're going to put a dot, and we're going to sketch this. It's going up and to the right. So the domain of this graph, since it is everything bigger than 2, is x is greater than or equal to 2. It says state the restrictions. Now restrictions are values that are only true for x. In this case, the restrictions are the same as what the domain is. They're like the values we can use for x in this expression. So it's x is greater than 2. Now it says explain how you could determine the restrictions algebraically. Well, if we look at this radicand underneath the radical, the x minus 2, we're going to set it has to be greater than or equal to 0. We cannot take the square root of a negative quantity. So we know that whatever quantity we get underneath the radical has to be positive. Now if we add 2 to the other side of this expression, that gives us our restrictions. X has to be greater than or equal to 2. And we have to know what the restrictions are because later on in this lesson we're going to solve some equations, and the equations are only defined for your values in your restrictions. And so if you get an answer outside of your restrictions, you know that that answer is not possible in the solution. Okay, the third graph we're going to look at is 3 minus 2x. So this particular graph starts at 1.5 on our x-axis, and it actually goes to the left. So some radical equations and graphs of radical equations will go to the left. Not all of them go to the right, like our first 2 examples. It says state the restrictions. Well, in this case, our x values are getting less than or equal to 1.5. Or you could have written that as a fraction, 3 over 2. It says determine the restrictions algebraically. So again, we know that what's underneath the radicand has to be greater than or equal to 0. So we set this greater than or equal to 0. Now, I'm going to subtract 3, and I get negative 2x is greater than or equal to negative 3. Now, something we need to remember, we've worked with inequalities before, but we need to remember that when we divide by a negative, that changes the direction of our inequality. And we get x is less than or equal to 3/2, which is exactly the same thing we got when we looked at it graphically. So the first thing you need to be able to do with any radical equation is be able to determine its domain and be able to determine its restrictions. That's the first step in solving it. So this portion, that's why we spent, a little bit of time looking at this. Now, what we're going to look at is we're going to determine the restrictions for each and every, we won't do necessarily every single question here. We're going to pick out some questions and determine the restrictions. Remember that whatever's underneath the radicand has to be greater than 0. So we get 4x plus 1 is greater than or equal to 0. We subtract 1, we get 4x is greater than or equal to negative 1, and we divide by 4, and we end up getting x is greater than or equal to negative 1/4. We do not change the direction of the sign here because we did not divide by a negative. If we look at C actually has 2 radicals in it, so we have to do restrictions for both of those. So if we look at this, we know x minus 2 has to be greater than or equal to 0, and x minus 4 has to be greater than or equal to 0. So if we look at this, we get x is greater than or equal to 2, and x is greater than or equal to 4. Now, you have to look at both of these restrictions. And you have to choose the largest one, meaning the one that if you looked at a number line, if we took a number line and went 0, 1, 2, 3, 4, one of our restrictions says we have to be greater than or equal to 2. The other one says we have to be greater than or equal to 4. Well, if we look at that, the region that overlaps, that is included in both of these restrictions, is x is greater than or equal to 4. So that is ultimately our restriction. We cannot use values like 2 or 3 because if we put 2 or 3 in the second radical, we're going to get a negative and then it's undefined. If we look at this third situation, again we have 2 radicals that are here, and you're going to have x plus 2 is greater than or equal to 0, and 3 minus x is greater than or equal to 0. So x has to be greater than or equal to negative 2, and 3 has to be greater, or x has to be less than or equal to 3. So x is greater than negative 2 and x is less than 3. So what that actually means is, in this case, our restrictions are between those values. If we look at this on a number line, here's 3 and here's negative 2. And it says x has to be greater than negative 2 and x has to be less than 3. So the overlapping portion is the portion between negative 2 and 3. And how we notate that our overlapping portion or our restriction is that region is we put the x in the middle. Hold on, this should be positive 3 and negative 2. We put our lowest value on the left and our highest value on the right. So that's determining restrictions.